Hello and welcome to using Minitab to do some statistics. Today I'm going to be doing hypothesis testing for proportions on Minitab Express. So as you'll see, I have Minitab Express open on the left with the data for this these notes open. So if you don't have the data file downloaded and opened, please make sure you do that before trying to follow along with this, because if you don't have the data, it's kind of hard to do the assignment. So the first thing you're going to notice is that we're looking at some school data. So these are business students, 5,000 of them to be exact. And I have some information from them, like what class they're from, what their major was, and whether or not they responded to the survey. So you notice this one is just 0 and 1s. This is called an indicator variable. 1 for yes, 0 for no. Since we're not using that one at all, we can just go ahead and ignore it. What we are interested in this first question is seeing, hey, did I get an overrepresentative sample? So you're assuming that you've got some uniform distribution amongst your classes. So you've got equal representation from each class, freshman, sophomore, junior, and senior. So since I'm just interested in the sophomores, that's going to be defined as my success, and everything else is going to be defined as my no. These are proportions. So what I have to communicate to Minitab is that I want to make sure I'm only counting them. So I'm going to do this as text with yeses and nos. You could just as easily do this with like 0s and 1s, just like the response variable. So I'm going to go on up to data, and I want to do to text. So like I said, if you wanted to do 0s and 1s, you would use to numeric. I'm going to use to text, and I'm going to recode the class variable. So I'm going to double click and throw class in there. It's going to ask me what I want to use. So I want to record these guys all as no's, and then my sophomores as yes. The big thing to be careful about here is that all of your no's need to look the same so that they look like the same value, or the failure value. So if I like accidentally put in a lowercase no in here, for juniors, that would actually make it look like there are 3 options in the variable that we're going to be testing here. And we don't want that. We're only interested in sophomores in this case. So the big thing with this is if you're only interested in 1 out of 4, the only way to do that is to make sure that your recodes all look the same. So I always go in and I check to make sure I don't have any extra spaces to one side. So I'm like, you can't tell this because I'm hitting on the keyboard, but I'm hitting like an over arrow and then over again to see that if I've got a space in there. And that's just a good habit to get into to make sure that you don't accidentally code poorly. What else do I want to say about this? Other than that, the other thing I recommend you do not do, again, do not do this. You'll notice this box at the bottom that says store recoded values in the original columns. That overwrites the column that you already have. That destroys the data you already have. I never check this box because I want to make sure that I keep my originals, which is always a good practice to have when you're dealing with any kind of data analysis. So I'm going to go ahead and hit OK. And you'll notice you have this new variable recoded class. It's kind of neat because it gives you counts of all the ones it recoded in this record up above. And you'll notice that, yes, it's doing its job. So everybody is getting labeled as a no except for your sophomores. So that's good. All right, moving on to B. Let's state our null and alternative hypothesis. So since we know that we want everything to be equal and there are 4 options, my null, aka I think nothing's going on, is that my proportion is actually a quarter, or 1 out of 4, because I'm looking at just one class and it needs to be equally present in the 4 options. My alternative is I don't think that's happening. So I think that my true proportion of sophomores is actually more than the rest of the classes, so more than 25%, or 0.25. I am going to use 0.25 since that is a proportion. Do not use 25%. Again, Minitab only takes decimals, so I don't know if you're real comfortable with proportions versus percentages, but you should be real comfortable with the proportions. Let's actually perform the test. Sorry, I'm going to want to copy things into here, so I'm trying to space it. Why am I recording this? Anyway, so to do this, we're going to go to the Statistics tab, and then we're going to go down to one sample, and you'll see the one proportion test at the bottom. and then it's going to ask you for some options. So there's a couple different options that you have here. This first drop down menu has them in it. So I'm going to click this so you can see it. So I'm on sample data is in a column. That's what we have right now because we have our data in the column. But there's also another option of summarize data. So if you're someone who is looking at a homework assignment and they're like, oh, 30 people said yes out of 47, you would put that in here. So you'd be like 30 out of 47. Oops, 47. And it's exactly like what the proportion would look like, the fraction, the number that said yes, that agreed to the event, that were your successes out of the total number of trials. So just like the binomial. We don't have that, we have raw data. So I'm going to go back to the sample data column. Cool. So I want to put recoded sample in there. My event that I'm interested in is the yes. You can also drop down this and change it to no. So if you accidentally recoded with no's in the wrong spot and yeses in the right spot, there you go. Then I want to perform a hypothesis test. And it's asking for your hypothesized proportion. That's always your value that you're interested in. Real quickly, I'm hoping you notice that when you look at your hypotheses, they always look like this. Your null should be a statement about sameness or equality, and it should have a value in there. And then your alternative can be lots of different things, but the point is you need to be testing the same value. Let's hit options. Cool. This is what I'm going to need to change. So alternative hypothesis is currently set to not equal to. That doesn't match what I have for my alternative. I think it's a greater than. Greater than hypothesized value. Remember, that's that 0.25 you put in earlier. And proportion, that's your P. And then it's asking, what's your confidence level? 95%. That works for now. There are some other options in here. So if you're doing a 99%, which comes up later in number 2, there you go. So 95. And then the last thing you need to be careful about is there's actually 2 methods to calculating this, the exact method and the normal approximation. We're using the normal approximation. You must always change this to a normal approximation. If you listen to nothing else I say in this video, please, 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 please don't forget to change your method to normal approximation. If you're doing your homework and using Minitab, if you don't change this to normal approximation, you will get all of your things wrong. And you won't know why, because you'll be doing all the right steps except for one thing. Oh, maybe you will know why, because I've warned it like super mega importante. I don't know what to do to get your attention. Woo! I really hope you guys don't just watch these videos with the sound off. Anyway, we're good to go. Let's hit OK. P.S. Since I'm doing a hypothesis test, this confidence level part really doesn't matter. Okay. Woohoo! So what we need is the test. So the first thing I always check when I'm doing these is making sure my null and alternative matches what I have here to make sure I'm doing the right test. And then the next thing it gives you is what you actually need. So notice the z-value and the p-value. These are going to be what tells me what I need to make my conclusion. So I'm going to post those in here. Notice my p-value is very small. And hint, hint, remember, small p, we don't want none of that p. We should reject p's that are small because we want big ones, right? So when you see a small p, you should reject the null. So now I want to state my conclusion. And here's where you need to be careful. Remember, when you're stating your conclusion, you should be saying something about the evidence and what it has shown you, and it should have context. So I need to mention the fact that it's a sophomore class that I'm interested in and what I saw with this sample. So small p means I'm rejecting the null. It looks like it does have more. So there is sufficient evidence to suggest that the proportion of sophomores, you're going to get real good at spelling sophomore, sophomore, sorry, in the sample is more than the other classes. Ugh, I don't like how I phrase this. Fix this. I want to say that there's a higher proportion of sophomores in the sample with a p-value. I always like to list my p-value of 0.0102. Couple other things to notice. Notice p-value is capitalized because it is a probability. All probabilities get capitals. We usually use little p for proportion to distinguish the difference between them, unless we're actually writing a sentence. I actually hate how I wrote this. Another way you could say this is you could also say there's insufficient evidence to suggest that the proportion of sophomores in the class is equal. So you'd be like, it's not the null. Or you could say, it looks like the alternative. So there's a couple different ways you could phrase that. Okay, since we're pretty certain it's not 25% and that it's actually higher, what we should do is calculate ourselves a confidence interval for this guy. So that's what I'm going to do for number 2. Let me hit enter a couple times to get a new page for this one. Actually, I do want to be able to compare these, so I got to be careful. Spacing. This is just the most interesting thing to watch, right? Right. Okay, cool. So what we're going to see is that with the proportion testing and with the mean testing, which is what we're doing next week. Is it next week? Something like that. Next time. There, nice and vague. That they're all in the same menu. It's just a matter of checking a box. So we're going to go back to one sample, down to proportion. You just got to do one thing. Okay, wait. Hold on. I got to throw in my coded sample, and then I'm going to not check the hypothesis test box because I don't want a hypothesis test. I want a confidence interval. Pretty nifty, right? All you got to do is not check the box. But be careful. Here's where you got to be careful. You have to make sure that you double check this options box because you should always check your options, number 1. And number 2, you got to make sure that this is doing the right thing. So again, you got to make sure on normal approximation. I want a 99%er, which is more accurate than this. This was like comparing to 5%. So yikes, this might not match. So hit 99%. And the last thing you want to do, I'm going to move this over just a little bit so you can see this, is that you got to make sure that you leave this as a not equal to, regardless of whatever hypothesis test you were doing earlier. That's why I gave this a new number. These are on the same data, but not related. Even if they are related, you're going to have to do this. So even if I gave you like F, find the confidence interval, you should still do this. Because if you don't do the not equal to, it's going to give you something like this. So if you look over at the descriptive statistics from the other one sample proportion test I did, it gives you a lower bound for the 95% confidence interval. So it only gives you part of it if you do a greater than. It's also only going to give you the upper part for the less than, which is interesting. But at the same time, I want both because I want the confidence interval. So that's why I have to set this as not equal to. So again, not equal to every time for a confidence interval. Make sure you check your confidence level and that you're on normal approximation so that you're in the right mode. Then we hit OK. I like this because it always gives you a little graph of it. Looks kind of like a TIE fighter. That's fun, but it's kind of like meaningless unless you know for sure what you want. So what's interesting about this is, remember the value that we're testing, scroll on up here, is 0.25. And it's like, it's in the 99%er. What's interesting about this, though, is it's obviously not in the 95%er, 5% chance of error, or 5% level of significance, because we rejected at that level. So this is at 10, about just bigger than 1%. Hey, 99%, what's left over for 99%? 1%. So this is just big enough to be in there. Kind of trippy, right? So to finish this out, I should write out what we have here. So confidence interval. Oops, I missed my ah. 0.2489, comma, 0.280261. All right. So the last thing I would do here is I would write a interpretation of this. So notice 0.248, 0.25 is just barely in there, just barely. But we should say we are 99% confident, which is pretty confident, that the proportion of sophomores is between 24.819% and, ooh, I missed a 3 in there. Whoops. I just noticed that. My bad. Oh, my 4 didn't come through. My buttons are sticking. That's weird. I think I need a new keyboard. 28.0261%. Don't tell IT because I already asked them for too many things. Okay, so couple things about this. So notice that your range of values here is about 4%. It's slightly bigger than that. It's almost 5%. And that's pretty typical. We want to keep our proportion or a spread of our proportions kind of small. We want our margin of error to be small because that means we're going to be more accurate and we're more confident here because it's at 99%. And one of the reasons why this is so small and so accurate is because look at the size of our sample. 5,000. It's huge. So of course this is pretty accurate. All right. I've diatribed enough about this. Hope you enjoyed. Go do some homework.